Welcome, everyone. If you are gearing up for the Cambridge Mathematics exams, specifically looking at the AdMath 0606 syllabus today, you already know that it can feel less like a standard test and a whole lot more like an absolute intellectual marathon. And look, just like a marathon runner has to rigorously manage their energy, pace themselves over miles, and relentlessly study the route before race day, you need a bulletproof strategy to manage your cognitive load during these exams. So today we are opening up the ultimate insider's blueprint. We're totally bypassing that generic run-of-the-mill advice to look directly at what the Cambridge principal examiners are actually telling us. To set the stage, I want you to picture two different students tackling a real Cambridge past paper question. Let's call them Alex and Sam. Now, Alex is the kind of student who overloads on raw mathematical facts, memorizing every single formula under the sun, but with zero actual analysis. On the other hand, we have Sam. Sam just rushes in, adrenaline pumping, and completely misses the specific requirements hidden in the command words. If we put their answers side by side, it's just a sea of red pen marks. Why? Because they didn't pace themselves and they didn't understand the rules of the race. Today, we're going to fix that. We're unpacking the theoretical foundations, the technical methodologies, and the critical evaluation skills that separate the top-tier candidates from the rest of the pack. Let's transform the way you tackle this exam.
Now, before we get into the really heavy lifting, I want to release some of that pre-exam tension right away. Let's talk about Alex for a second. Alex spent 3 straight nights crying over highly complex, multi-layered permutation scenarios, trying to figure out how to arrange identical objects in a circle while combining them with specific selections. Total nightmare, right? But listen to this explicit syllabus guideline regarding permutations and combinations. It literally states, problems involving repetition of objects, objects in a circle, or both permutations and combinations are not included. Take a deep breath, let that really sink in for a moment. One of the absolute biggest mistakes students make in their marathon training is carrying unnecessary weight in their backpacks. The examiners are explicitly telling you, skip it. It is not in the 0606 syllabus. Knowing exactly what not to study is just as crucial as knowing what to study. It saves your precious mental energy for the areas where you can actually score points.
All right, so here is our structured roadmap for today's explainer. We are going to systematically cover, number 1, syllabus boundaries revealed. Number 2, core theoretical principles. Number 3, the technical methodology. Number 4, critical evaluation skills. And finally, number 5, top examiner warnings. We're going to move fast, but we're going to cover everything you need to know. Okay, let's dive right into section 1, syllabus boundaries revealed. This is all about exactly what you should completely ignore. When you are deep in your revision zone, or maybe you're looking at older past papers or even different syllabus codes like 0580, 4024, 4037, or 4040 that might mix some of these concepts up, you have got to be completely ruthless. If a problem involves the repetition of objects, cross it out, done. If it involves arranging objects in a circle, skip it. If it involves complex scenarios that mash up both permutations and combinations into a single convoluted step that falls right outside the standard 606 syllabus scope, ignore it entirely. Remember our student Alex? Don't be like Alex. Your cognitive energy is incredibly precious. By strictly observing these exact boundaries, you are ensuring that every single minute of your study time is directed toward accessible, point-scoring material. It's about working smarter, not just harder. Now, before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGC, to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Moving right along to section 2, core theoretical principles. We've dropped the dead weight, so now let's focus on the foundational knowledge that actually wins the race.
Here is the crucial point that trips up our other student, Sam. AdMaths is absolutely not just about blindly memorizing formulas and regurgitating them. The syllabus explicitly targets specific assessment objectives across distinct cognitive domains. It tests your knowledge, your understanding, your application, and your deeper analysis. So what does that actually mean for you sitting in the exam hall? It means the theoretical architecture of a top-scoring paper relies on precise definitions and a crystal-clear understanding of causal relationships. When you apply a mathematical principle, you need to know exactly why you are applying it, not just how. You are essentially building a logical chain of evidence. If A is true, then B must inherently follow. This is where top students use a structure similar to the Peel framework: point, evidence, explanation, link, even in mathematics. You state your mathematical point, you provide the formulaic evidence, you explain the working, and you link it back to the specific command word of the question. This is the exact evidence-based reasoning that elevates an answer from basic robotic processing to true advanced mathematical mastery. Sam misses this because Sam rushes. Take your time, decode the command words, and build your case. And check this out. Here is a massive insight pulled directly from the principal examiner reports. They explicitly note, candidates referencing cross-topic connections achieve significantly higher marks. Listen, the examiners are practically handing you the golden key to the top grade boundary right here. Top-performing students do not view algebra, geometry, and calculus as isolated, walled-off silos. They exhibit a connected, conceptual understanding that seamlessly transfers to totally unfamiliar contexts. So if a complex calculus problem suddenly requires a trigonometric identity to solve, the student who instantly spots that cross-topic connection is the one who walks away with the maximum marks. It's like seeing the Matrix. You have to look at the whole paper as one interconnected ecosystem.
All right, let's turn to Section 3, the technical methodology. This is where we take the theory and turn it into a systematic, step-by-step processing engine.
Let's look at your examiner-approved procedural framework. This is your mathematics success blueprint. If we were to sit Alex and Sam down right now and have them rewrite their botched answers live, this is the exact 5-step sequence we would force them to use to turn those red pen marks into green check marks. Step 1. Deconstruct the question. Do not just start wildly calculating. Read the text, decode the specific command words like evaluate, derive, or show that. Identify the key elements and understand exactly what is being asked. Step 2. Extract the relevant data. Pull out the numbers, identify the given variables, and note any strict constraints. Step 3. Select your analytical framework. Apply the relevant theoretical principles we just talked about. Which specific formula? Which mathematical rule? Step 4. Execute with clear notation. This is absolutely vital. Perform your analysis with systematic, step-by-step clear working. Verify your intermediate results as you go. And finally, Step 5. Present with correct terminology. The presentation of your information must follow strict Cambridge conventions, proper headings, correct mathematical terminology, appropriate formatting, and clear annotation. If you follow this standardized sequence every single time, you completely eliminate panic. You transform a chaotic, stressful exam experience into a cool, manageable, highly predictable process.
We are now entering Section 4, Critical Evaluation Skills. This is all about higher order thinking. But hey, stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
Okay, let's get interactive. Welcome to the workshop phase. I want you to mentally picture a really complex add maths data table or a convoluted graphical chart right in front of you. You've got 60 seconds on the clock. Go. A lower-tier student looks at that data and uses a purely descriptive approach. They just state what is happening on the surface. The line goes up. That's Alex, just reading facts. But an evaluative approach, the top-scoring approach, is entirely different. If we look at a flawed sample paragraph describing that data, where do the marks bleed out? They bleed out because the student doesn't question the why. Top candidates don't just describe, they evaluate alternative scenarios, they compare different analytical approaches, and they make mathematically justified recommendations based entirely on the evidence they extracted. They rigorously deconstruct the problem, solve it, and then critically evaluate their very own solution to make sure it actually holds water. Let's break down exactly what that elite evaluative thinking looks like in practice using these 4 critical checkpoints. I want you to imagine a 30-second speed writing timer counting down right now. If you had to write one perfect paragraph justifying your math, you'd run it through this filter. First, identify limitations. Are there constraints on the domain or range that you totally missed? Second, uncover assumptions made. Did you casually assume a variable was positive when it actually could be negative? Third, spot alternative interpretations. Is there another completely valid way this initial data could be read or manipulated? And finally, check for reasonableness. Look, if you calculate the probability of an event happening and your final answer is 1.5, your critical evaluation skills should immediately sound a massive alarm bell in your head. That is mathematically unreasonable, and it should immediately prompt you to loop back and review your standardized sequence. Top candidates always question their own assumptions, and they justify their final decisions with rock-solid, irrefutable evidence. We are now in the final stretch. Section 5, Top Examiner Warnings. This is where we reveal the biggest traps and how to avoid them to guarantee top marks. These are the top 3 unforced errors pulled straight from the examiner reports. If you want to guarantee top marks, treat these as the 3 golden rules of what not to do. Number 1, answers are often way too vague. Examiners are incredibly smart, but they aren't mind readers. They demand specific, highly detailed mathematical reasoning. If you skip steps in your logic because you did it in your head, you lose marks. Number 2, students completely forget format and presentation conventions. Remember step 5 of our methodology? Correct terminology and clear annotation are not polite suggestions, they are required strict conventions. Number 3, answers completely lack specific context. If a problem is framed around a real-world scenario, say calculating optimal velocity, your final answer needs to actually make sense within that real-world context. Do not just leave a naked floating number at the bottom of the page if the command word demands a contextual conclusion.
And this, my friends, brings us to the absolute ultimate safety net, the method marks strategy. In Cambridge Odd Maths, marks are heavily awarded for the journey, not just the final destination. The method mark strategy simply means that if you demonstrate the correct procedural steps, if you correctly apply the right analytical framework, and if your working is logically clear, you will accumulate marks. Even if you make a totally silly minor arithmetic error on the very last line of the page and your final conclusion is dead wrong, the method marks will completely save your overall grade.
I literally cannot emphasize this enough. Always show your working. The absolute biggest, loudest examiner alert from all the reports we analyzed is that students lose massive, catastrophic amounts of marks simply by doing calculations on their calculator and not writing the steps down. If you just write down a wrong final answer, you get a flat 0. But if you show the brilliant, systematic, standardized sequence you used to get there, but you just dropped a negative sign at the very end, you might still get 80% or even 90% of the total marks for that specific question. Showing your working is exactly how you pace yourself, it is how you build your undeniable chain of evidence, and it is your absolute best impenetrable defense against a brutal exam paper. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos.
So as we wrap up this marathon, I want to leave you with a really provocative question. When you are sitting at your desk studying tonight, are you practicing just to magically find the final answer, or are you relentlessly practicing the process? Because mastering the process, the clear working, the precise definitions, the evaluative checks, that is what actually wins the race. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCE to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here. Thank you so much for joining me in this explainer, and I will see you next time.